now we're going to look at the 2017 FRQ number 3. And we're given a nice graph. It's the graph of the derivative, so that's going to be important. F is differentiable. Cool. That means it's continuous on the closed interval -6 to 5 and satisfies that f of 2, -2 is equal to 7. The graph of the derivative is a semicircle with 3 line segments. Cool. Find the value of f of -6 and f of 5. Okay. So f of -6. Well, if I want to know f of -6 and I have the derivative, I'm going to go ahead and integrate the derivative. And I'm going to make sure I use the one value I know, which is -2. And I'm going to use the value I want, which is -6. So it's -6 to -2. And this is going to equal f of -2 minus f of -6. So this is going to give me the value I want in a second. Okay, so what I'm going to do is I'm going to start evaluating things. So the first thing we're going to do is find the integral. So -6 to -2. So right here is -2. So I'm going to find the area of that triangle right there. And this distance is 1, 2, 3, 4, and this distance is 2. So the area is 1/2 times 2 times 4, which is a nice 4. So then this is going to be 4 is equal to 7 minus f of -6. So -3 is equal to -f of -6. 3 is equal to f of -6. Okay, and then we want to find f of 5. So same idea, we're going to integrate from -2 to 5 of f prime of x dx. And that's going to equal f of 5 minus f of -2. So from -2 to 5, we're going to look at this semicircle, and we're going to look at this triangle right here. Okay, so for the semicircle, we have a radius of 2. So this is going to be pi r squared over 2 because it's a semicircle. So it's 4 pi over 2, which is 2 pi. Keep in mind, because it's below the x-axis, it's going to be negative, not positive. The height here is 2, and the base here is 3. So we get the area is equal to 1/2 2 times 3, which is a nice 3. So the integral then is going to be 3 minus 2 pi is equal to f of 5 minus, and f of -2 is 7. So I add the 7, I get 10 minus 2 pi is equal to f of 5. Part B. On what intervals is f increasing? Justify your answer. So we want to know where f is increasing. So f is increasing when f prime of x is greater than 0. So then we just go to the graph and find out where this thing is bigger than 0. Well, it's bigger than 0 here, here, and here. So from -6 to -2 and 2 to 6. I'm sorry, 2 to 5. So f is increasing from -6 to -2 and 2 to 5 since the derivative is greater than 0. Part C, find the absolute minimum value of f on the closed interval -6 to -5. So absolute min, we're going to look at setting that derivative equal to 0. So you want to set f prime of x equal to 0. And not only that, we want to find out where it's also undefined, but really we're not going to have that. We only need to look at certain places. So you have a min when f prime of x changes from negative to positive only. And the endpoints, right? You could have it at the endpoint. So this thing changes. First of all, let me kind of clean this up. So right here is where it changes from negative to positive, and we got to make sure we check the endpoints. Okay, so this happens at x equals 2. And then we also have to check the endpoints of x equals -6. And we don't need to check the last endpoint because it's going to increase. So if I draw a sign chart, again, sign charts don't count as work on an AP test, but they're definitely helpful to kind of see what's going on. My graph is going to go up, down, and up. So this is going to be a max, so you don't have to check this one. We have to check the -6, and we have to check the 2. So we know that f of -6 is equal to 3. All right, so we need to find f of 2 now. So in order to find f of 2, we're going to integrate. So we integrate from -2 to 2 f prime of t dt is equal to f of 2 minus f of -2. So when you integrate, that's the area underneath the semicircle, which is -2 pi is equal to f of 2 minus 7. So it's 7 minus 2 pi is equal to f of 2. And 2 pi is about 6. So this is about 1, which is definitely smaller than 3. So then we have the absolute minimum is 7 minus 2 pi at x equals 2. Okay, and then part D, it says find f double prime of -5 and find f double prime of 3, or explain why they do not exist. So let's go up to the graph. -5 is right here, and 3 is right here. So if I look here, I'm trying to find the second derivative, which would be the slope of the first derivative. So I just do rise over run. I get -2 and 4, so this is -1/2. And then here, it's a corner. So the derivative won't exist, but we need a better reason than that. And our reasoning is the slope from over here is -1, and the slope from over here is 2. So f prime of -5 is -1/2, and this is DNE since f double prime of 3 from the right is equal to -1, and the derivative from the left is equal to 2.